Ideol has just secured funding from the European Commission for the lead float project. Can you tell us a bit more about it and the importance of the government support when it comes to commercializing new technologies?
Yeah, first I have to say it's a very, very big honor for us to receive this grant, because there were 1,200 organizations that applied for funding, and there is only 60 who received a grant, so 5% return, and we were successful, which is a great success for us. The money is going to be used, or the program is for commercializing businesses, small, medium enterprises into commercial competitivity. And that's exactly what we will do. There is two aspects that we will mainly pursue. One is the development of floating substations, which we will bring to commercial feasibility stage. We're studying that at the moment, and this grant will allow us to do this in more depth and more detail than we would previously have anticipated. We're making good progress on this. And the other half is dedicated to commercializing an internal R&D project to reduce the cost of generation from floating wind based on our concept by serialization, industrialization and innovation. We're doing that on the basis of the next generation turbines, which will also be instrumental and very important to bring down or to achieve the economies of scale and to bring down the generation cost. And that's where we will use these funds for. Well, there's lots of challenges because we're breaking new ground. There is a lot of technology that is in the market, but this is not comparable to our shallow floater concept. You have to imagine it's a square shape with a big moon pool in the middle, and it's very shallow. It can operate in water depth as little as 30 meters. That makes it very unique, and we had to learn a lot about the engineering, mainly the coupling of the mooring responses with the reactions of the hull, the hydrodynamics of the hull, the responses of the wind turbine and the loads of the wind and the wind turbine itself. All these dynamic loads are being put into one computer model called coupled analysis, and that's a big challenge to get this right, because it's a very new technology, and we're benchmarking this new modeling approach against the heavily instrumented results we get from our prototypes so that we can narrow down the uncertainties that we used to have in the modeling and improve the economics of the whole thing. That is one of the challenges. The other challenge is very obvious. It's bankability, and you have to have demonstrators in the water. You have to prove with full-scale demonstrators that the technology actually works, so that you can do the next step, a pilot project, and then the next step of commercial scale projects with several hundred megawatt scale. And these need to be financed by banks and need to be insured. And this insurance can only be granted if you have delivered the proof of concept with demonstrators.
How large would the first project with floating wind turbines need to be to prove the commercial maturity of the technology?
A difficult question. It depends very much on the market where you are. So in Japan, where the electricity prices are high, a smaller project might be economically viable. Whereas in a market where electricity prices are very low, like in Northern Europe, it would need to be very big to get the economies of scale. My assumption is that the minimum to get near commercial competitivity with other forms of electricity generation, clean forms of electricity generation, would need to be 300 megawatts upwards.